In this EZEd video lecture, we are going to learn arrays, which includes one-dimensional arrays, two-dimensional arrays, and multidimensional arrays. Let's start with the introduction to arrays first. We have studied fundamental data types like the int, float, double, void, char. These are very useful, though they are constrained by the fact that they can store only one value at a time. But in many applications, we are needed to handle large volumes of data for reading, writing, and processing. To support such needs, we require a powerful data type that would facilitate efficient storing, retrieval, and manipulating of data items. Thus, C provides a derived data type known as array to handle such needs. Let's take an example where the user will have to print the input in reverse order. The program would be this. If there are 3 values, then also the program would be easy. But if the number of inputs is increased to 100, then the program won't be so easy. This problem can be solved using arrays.
Seriously, pay attention. This is important.
An array is a fixed-size collection of homogeneous data items. It stores ordered sequence of like-type data. An array is thus defined as a data structure consisting of an ordered set of values. Thus, this array of 1, 2, 3, 4 is different from 1, 2, 3, 4. An array is used for representing a list of temperature records, employees of a company, and test scores and so on. In C, each array has 2 fundamental properties. Data type, this defines the type of data items. Size, it defines the number of storage locations. Each element is identified by an index number, which is an integer starting from 0 or 1. The ability to use a single name to represent a collection of items and to refer an item by index number enables a programmer to develop powerful programs. Arrays can be used to not only represent simple lists but also to store tables of data in 2 or 3 dimensions or more. Thus, arrays can be one-dimensional, two-dimensional, or multidimensional. Let's learn one-dimensional array first. The array which is used to represent and store data in a linear form is called as single or one-dimensional array. In mathematics, we have come across this equation which calculates the average of n values. Here xi refers to the ith element of x. Similarly, in C, a list of items can be assigned one variable, name, and using a single subscript, we can refer each element of the array. Such a variable is called as one-dimensional array. The subscripted variable x is expressed as, in the memory, the variable x is assigned storage as below. Moving on to the declaration of one-dimensional array. We need to declare the array in order to use it in a program. 3 things should be considered while declaring: the type of data it can hold, number of values it can hold, a name. Suppose we want to represent 5 numbers in an array. Here, data type is int, number of values is 5. Name is any name which can be given to the array, say num. So it is declared as int num5. Any reference to the array outside its prescribed limits will not necessarily cause an error, but might lead to unpredictable program results. Size can be numeric constant or symbolic constant. The compiler reserves 5 consecutive locations in the memory on encountering the above statement. Examples are float weight 10, char str20. The character array is used to declare a string which is considered as an array of characters. Thus, this line declares str as a character array which can hold maximum of 20 characters. If we read hello there in the character array named str, then it will be stored in the memory in the following way. The compiler automatically terminates the string with a null character /0. Thus, while declaring a character array, we must allow one extra element space for the null character.
Hey, it's time to concentrate now.
Moving on to the initialization of one-dimensional array. After declaring the array, we have to initialize it by assigning it the data items. Otherwise, it will have all garbage values. It is initialized in either of the following stages: compile time, run time. Considering compile time initialization first. This is the general form. Initialization is done in the same way as it is done for other variables. This will declare an array named num of size 5 and assign values to each element. This will cause the data items to be stored in the memory locations. Thus the numbers are assigned with num1 being assigned the value 1 and num2 is assigned the value 2 and so on. The subscripts are used to index the array. Similarly, this will reserve 100 memory locations. If the number of values in the list is less than the size of the array, then the remaining elements will be assigned 0 if the array type is numeric and a null character if the array is of character type. However, if the number of initializers is more than the array size, then it will lead to a compile time error. We can eliminate the size of the array, and so the compiler will automatically assign enough space for. Once declared, the array element can be referenced in this way. So fifth element of array num is referred in this way. Even variable size declaration is considered as illegal and leads to compile time error. Here in this example, as n is a variable, it will lead to variation and leads to compile time error. Moving on to runtime initialization. Arrays can be explicitly initialized at runtime. This approach is used for initializing large arrays. We can also use scanf function to read the array elements. Let's learn how to assess the array elements. Single operations which involve entire array are not allowed in C. Operations can be performed on individual elements by accessing them using their indices. If all the elements are needed to be accessed, then we can use a loop.
Seriously, pay attention. This is important.
Program. Let's try to understand declaration, initialization, and declaration of the array. We start by declaring the main function followed by the array n, which is of size 10, and also the variable I, j. It is initialized with the values 100, 101, and so on till 110 using the for loop. And finally displayed as the output again using the for loop, after which we end the program. Now we will learn two-dimensional arrays. Arrays having two dimensions is termed as two-dimensional array. It is visualized in the form of a table. Let's take an example of a table storing the roll number and marks of 3 students for 4 subjects. This table appears like a matrix of 4 rows and 3 columns. Each row here represents the marks scored by each of the 3 students in each subject, while each column represents the marks scored by each student in all 4 subjects. In mathematics, each value of the matrix is represented by Vij. So I and j are subscripts to locate a value. So V12 is 21. This type of table is developed in C using a two-dimensional array. Moving ahead on declaration of a two-dimensional array. This is the general form. Thus for the student example, we will declare it as. This will cause the compiler to reserve memory space for the array named marks. The first index specifies the row, and the second index is used to point out the column. Now we learn the initialization of two-dimensional array. Like the one-dimensional arrays, two-dimensional arrays should also be initialized after their declaration. So the values 23, 21, 24 are assigned to the first row, and 45, 46, 47 are assigned to the second row. Similarly for rows 3 and 4 too. We can also initialize the values in this way, or we can initialize it as. Note, observe the syntax carefully as commas are required after each brace. When the array is completed initialized with all values, the first dimension can be ignored. So, if values are missing in the initializers, then the extra zeros are automatically added to the array elements. The compiler automatically assigns 0 to marks 1, 1 and marks 1, 2. When we want to initialize all the elements to 0, we can use the following shortcut. Let's write a program to understand the declaration and initialization of a two-dimensional array. We start by declaring the main function followed by the two-dimensional array A having 3 rows and 3 columns. Then we ask the user to enter numbers. We use 2 for loops here. The outer loop is used to index each row and the inner loop is used for columns. We scan in the values inside the loops. Then we print the values, to which again we have to use 2 loops. Observe the output here.
Seriously, pay attention. This is important.
Lastly, we study the multidimensional arrays. Arrays with more than one dimension is termed as a multidimensional array. Though it is difficult for humans to visualize them, but it is simple to represent them in C. The limit on the number of dimensions is determined by the compiler. A multidimensional array is declared in this way, where di is the size of the ith dimension. The examples are: report is a three-dimensional array which can store 60 integer variables, while tab is a five-dimensional array which can store 2160 floating point values. The array report can be used to display stored data of temperature from Jan to May for 3 years for 4 cities. Thus, the first dimension is for years, while the second dimension is for cities, and the last dimension stores the months. Lastly, let's learn dynamic arrays. We have created arrays at compile time. The arrays created at compile time have a fixed size assigned to it while developing the code, and so it cannot be modified while running the code. This is termed as static memory allocation, and such arrays are called as static arrays. This is useful when we exactly know our data requirements. A situation where we want to use an array which varies in size greatly, we are needed to allocate the maximum size and create array accordingly. C overcomes this problem by allowing allocation of memory at runtime. This is known as dynamic memory allocation, and the arrays are called as dynamic arrays. Dynamic arrays are created using pointer variables and memory management functions malloc, calloc, and realloc. These functions are included in the header file named stdlib.h. Dynamic arrays are used in creating and manipulating data structures like linked lists, stacks, queues, etc. Let's have a quick review of what we've learned in this lecture. We started with introduction to arrays and learned that an array is a fixed size collection of homogeneous data items. Also, how an array is stored in the memory. Then we saw the arrays are of 3 types, namely one-dimensional, two-dimensional, and multidimensional. The array which is used to represent and store data in a linear form is called as a single or one-dimensional array. The declaration of a one-dimensional array involves the type of data it can hold, number of values it can hold, a name. The initialization of an array is either done in the following stages: compile time, runtime. Compile time initialization will lead to assignment of values when the source code is developed, while the runtime initialization results is initialization when the program is run. Then we studied two-dimensional arrays which are declared in this way. They are initialized in the following way. Arrays with more than one dimension is termed as multidimensional array. They are declared in this way.